The broadcast is now starting. All attendees are in listen-only mode.
Hello, ladies and gentlemen. Good afternoon and welcome to this webinar on Blueback Investigator 4. Today I hope to show you the latest features of the Investigator 4 through some different examples. Hopefully this will highlight our aim with the Investigator, which is to take it beyond visualization. First, a short note on how to participate today. We're using a GoToMeeting hosted session, and you should be able to open and close the panel using the orange button, and also switch between full screen and window mode should you need some more space to view the presentation. By default, everyone is muted, but you can put questions into the dialog box on the GoToMeeting panel, and we can try and answer them as we go along. If not, I'll take some time at the end to answer questions as well. We'll also send out a link to this recording to all of you within 24 hours so you can share it with any of your colleagues. Just while we're on the subject of webinars, we're running a series of webinars now throughout the fall, and I'd just like to mention that the next one will be in October, and this will be focused on the Blueback Blueprint, which is a tool for doing quality control and reporting on geomodels. But today I'd like to focus on the Blueback Investigator, and to start I'd like to mention a little bit about the background of the workflows I've chosen to show. So today I would firstly like to show you a bit about how to show and interrogate the distribution of data and understand the description of data and what that tells you. Then I would like to highlight on a multivariate analysis workflow, which simply means many variables, and show you how we can look at their correlation and pick out trends in the data. Then finally, I would like to focus on the classification and prediction of data to basically highlight how you can use the results back in Petrel in a meaningful way. During the presentation, I will do this by highlighting a number of features in the new Investigator. So these include the split plots, where we can create many similar plots based on a discrete dimension like facies or zone. So from a crossplot or histogram, we can instantly reproduce a similar plot for each discrete object. I'll also show the multi-histogram, where we can take a histogram and produce one for each dimension in our investigation, again speeding up time to create lots of comparable plots. I'll also mention the visual statistics, where we can annotate our plots with a box plot in the histogram window and a bag plot, which is a kind of 2D box plot in the crossplot window. And this is a way of tying together both the descriptive statistics and the plots. I'll also touch upon prediction equations, where we can use equations to predict missing dimensions or missing data. I'll mention the 3D window and some of the new filters we've added there and how that can help you in a multivariate analysis workflow. And I'll mention also that we've improved a lot of the performance and multi-well handling of the Blueback Investigator. So firstly, you may have heard the phrase that with statistics you can prove anything. Well, hopefully today that I can show you that this is untrue, and with the correct application of statistical techniques, in fact, we can reduce a lot of ambiguity and uncertainty in the interpretation of our data. So firstly, before I start the demo, I would just like to quickly mention what I'll show in each workflow. So firstly, I'll focus on the distribution of data and the description. So here I'll show how to use the GDI histogram window, produce descriptive statistics about the data, split up your investigation into different plots, and produce some visual statistics which help summarize the data. Secondly, I want to show you how to work with many different variables. So we're going to use the matrix plot to plot lots of different pairs of variables together. We'll produce a best fit equation and a correlation coefficient. We'll pick out trends in the data using the highlighter and the statistics, and we'll also display the principal components of the data set. Finally, what we'll try to do is to classify the data using filters and then show the results back inside Petrel. We'll predict new data using a best fit equation that we've created in the previous step. And finally, I'd like to share some tips and functionalities that we have for exporting the data into various things we can use in Petrel. So with that, I'd like to move over to Petrel and begin the demo. In the first example, I want to highlight the benefit of using the investigator to compare different facies in a well. This can be a time-consuming process in other packages, given the need to filter the data, set the plots to the correct axis limits and legends. So in order to do that, I'm going to use my investigation that I've created here, which consists of a single well, various petrophysical logs, and a facies log, which is a discrete dimension. Just before showing the data, I'd also like to remind you that in Petrel 2014, you create the investigation here from the object menu, and then you choose the data you want to add. Once you have that completed, you can then show in various windows like so from the input tree. So firstly, I'd like to start by showing the histogram window here with my single well displayed. So the histogram window shows the overall trend and most likely values of the data, which you can see here. Then I can also, for example, color by my facies, and I'll get here a histogram for each of the facies in my well. And I can, of course, adjust the style options to either separate these into separate bars or lines, just to make that comparison a little bit easier. Secondly, what we can now take advantage of is the split by option in the Investigator 4. So here I can use this option and split up these plots by my facies. So here you can see I then get a histogram for each different discrete dimension in my well, and of course I can remix these as I like to change the order or to turn ones off that I'm not interested in. Firstly, you can see that one of the main advantages of this is that all the plots are carefully linked together on the same axis scale, and of course can be appropriately annotated with a legend. So this saves you a lot of time in preparing a comparison plot like this. Secondly, I can also make use of the multi-histogram to display some more relevant dimensions in my histogram window. So here I can, for example, focus on a histogram of VP-VS ratio and acoustic impedance for each of the individual facies. So this makes it really simple to build up a kind of histogram matrix of different dimensions and different data objects. And of course, it's really simple to make an easy comparison between the different plots. Finally, I may want to quantify the difference between these different properties here, and I can do that by toggling the statistics icon in the histogram window. And when I do that, what you can see is I get then a set of descriptive statistics for each facies that I have and for each dimension. So here I have VP-VS ratio and also acoustic impedance. So that allows me to QC many different statistical options, like for example the mean and the standard deviation, which are useful description for the distribution of a data set and can be quite useful in many property prediction workflows such as Bayesian classification. Finally, I would like to take this workflow kind of full circle by showing you that we can also draw the statistics on this plot. When I do that, I get a simple box plot on each of my histograms. The box plot is directly related to the statistics and is in fact defined by the min and the max range of the data. The solid box is defined by the P10 to P90, and the solid black line is defined as the mean of the data. So here it was very easy to see how we can create quick, reproducible plots all with the same scale. We can produce our descriptive statistics to get a description of the data set, and we can also annotate this using the draw statistics to give a bit more meaning to the descriptive statistics. I would then like to move on to my multivariate workflow and show you the different tools we have for analyzing many variables. So again, I'd like to start just by showing you the anatomy of my investigation. I have a folder of wells with a number of petrophysical dimensions, and then a single well which I want to look at relative to the other wells in my investigation. So I'm going to start by opening this in a matrix window. So typically, the analysis of many variables can be a complicated process. Establishing and quantifying trends between many variables can be difficult with limited tools. As a rule, many suggest that variables should only be included in analysis if they contribute significantly to the dataset, and this can be quite difficult to define and difficult to decide. So in this manner, I can use the matrix window to make that process a little bit easier. Firstly, my matrix window displays each of my dimensions in my investigation plotted against each other. I can, of course, easily remix those dimensions, so I could, for example, take vClay off and choose to rather color by vClay instead. And what you can see is in this matrix of variables, I also have an area where I can use a histogram where the variable pairs are the same variable. We can also change the order of this matrix plot simply by dragging the matrix like so that you can build up a relevant order for your investigation. So when it comes to establishing trends in the data or quantifying the correlation, we can do a more sophisticated job of that by using the crossplot window. And in this example, what we can do is produce a best fit equation and a correlation coefficient, which will give us effectively a score or of the fit between the two variables. So I can start by example choosing porosity against gamma ray, and then from here I can create a linear fit equation like so, and by toggling the legend I can get access to the R squared or correlation coefficient. So what you can see is that this is a number which gives you a kind of score of the correlation between the two variables. So here I can see I have a fairly low correlation coefficient, and if I change to, for example, density against porosity and create a new best fit equation, you can see now that a correlation coefficient is relatively high, and I have a good correlation between these two variables. In the previous example, it's also possible to subset the data that you're using in your correlation by simply defining a filter. So here I can, for example, use a rectangle or polygon filter to change the fit of the equation and the data that's included in that best fit. When I do that, you can see that the equation updates and the correlation coefficient updates accordingly. Next, I would like to return to the matrix window to show you how we can use statistics to help show some different trends in the data set. So firstly, we can produce our descriptive statistics again, but this time in the matrix window we get then a set of statistics for each of the dimensions that we have. So here you can see I have a different tab for each of the dimensions in my data set. It's also important to note that the statistics follow the selection that you have, so you can toggle things on or off, and I can also use this folder wells and color by children, which will then give me a table of statistics for all the wells in my investigation. It's then possible to, for example, sort by any of the values in this table, and in fact maybe I can investigate the high variance in some of these wells, and I can make use of a tool here known as the highlighter, so that I can pick specific wells and highlight them on the plots, basically relative to all other data. So you see here with this well highlighted we get a new set of statistics calculated, and we can basically browse the different wells in the context of the overall trend. It's also possible just to hide the background data by toggling this icon here, which enables just a slightly simpler display of the same amount of data. Next, in a multivariate type scenario, it could also be nice to make use of our principal component analysis to get an idea of the directional trends in the data. Under my draw menu, I can toggle my principal components on and toggle my data off. And basically what this shows me is the two strongest directions of variance within the data set. So this can be a useful technique for getting a quick quality control on the directional trend or strength of different variables in your data set. Finally, similarly to the histogram window, it's also possible to draw the statistics for a given set of data. And again, we can do this in the draw menu. We can here draw statistics. So then what you get is effectively a box plot, but in 2D, known as a bag plot. So we have the same definition. We have the min and the max of the data drawn by this stippled line, the P10 to P90 range drawn by the solid, and the mean of the data drawn as a single point. So again, it's possible to include the other set of data and compare the statistical trends of the two objects together in this manner. Finally, when working with many variables, it may be nice to view them in a 3D to try and pick out some visual separations in the data. So that we can do by opening the Blueback Investigator 3D window. And we can choose our different axes here for the 3D plot and then browse around. In the Blueback Investigator 4, we've also increased the options for filtering in the 3D window. So we can add, for example, a box plot filter in the 3D space. So we can filter points here in 3D. So this can also be used back in our matrix window as a kind of QC. So here we can, for example, apply the filter that we've calculated in the 3D window and see how that corresponds to our data in the matrix window. And consequently, we can do the same. If we define a filter in the matrix, we can apply it in the 3D window. In the final section, I would like to highlight a few features which can help you integrate your results back into Petrel. So of course, all these analysis techniques are only really good if we can get some meaningful results. So with that, I'd like to return to my original investigation, but this time in the Crossplot window. Here I would like to show that it's possible to interpret the data on this crossplot and create something we can use in Petrel. In order to do that, I need to have defined some classification groups to fit the data. And once I've done that, I can then define here a set of filters which will classify the data. So I can first of all create some selections like so. I can also maybe use something like porosity as a guide for my interpretation here. Something like this, and I can then assign each of these a value, like shale, brine sand, and gas sand. And I can QC my interpretation by coloring. And once I'm happy with my results, I can right-click on a point and say Save as Classified Well Log. Once I do that, I then get something which I can use in Petrel. So you see here in my results window, I have a facies log which I can use in the well section window. In addition, we can add a little bit of extra context to our well section by maybe including some of the crossplot results. So here I could, for example, define a rectangle filter, and in my well section window I can maybe toggle on my investigation and color by porosity and just make sure it's using the right filter. And what you can see is I can then interrogate my crossplot together with my well section window and bring the data back into Petrel for something meaningful. Next, I would like to show you how it was possible for us to predict some data using a best fit equation. So I return here to my plot of porosity against density and with my best fit equation. So I'm now going to introduce a new well which may, for example, be missing one of these dimensions. So I can add to the GDI a new well, this 25, and I'm going to choose density, but I will leave porosity blank. And then by clicking on the column header here, I can say, instead of using a log, please predict porosity from this given equation, and then ask me to specify a dimension to calculate from. So by pressing OK, I can then get a new set of data which is predicted from this best fit equation. So I can compare how that data fits with the overall trend. Firstly, it may be a comment that our new prediction isn't valid for all of the data, in which case I can do something like define a simple one-dimensional filter, like so. So I can filter maybe for a specific range of gamma, and back in my porosity versus density plot, you can see that then I'll predict a few less points based on the selection of the gamma ray values. Finally, I'd like to show you how we can export some of these results back into Petrel and use them in a couple of our workflows. The first one I would like to highlight is the ability of GDI to save as a raw crossplot. So by doing that, we're saving a crossplot of this data and a trend that's in the plot. And that's something that you can, for example, use in something like petrophysical modeling. We could create porosity by feeding in our raw crossplot and say, for example, calculate our porosity from density using the crossplot and the relationship provided. Similarly, that's something you can also do with your best fit equations. You can also save them to a Petrel function. And again, that's something, for example, that can be used in your petrophysical modeling. You can include your best fit equations and distributions in this manner. Next, if you're not satisfied with the statistical techniques that the GDI has to offer, you may wish to use another application, in which case it's probably easy to export here to a spreadsheet, like so. And if I open up my Crossplot window, we can get a spreadsheet of the investigation, which includes all the relevant dimensions and data associated with that. So here we can see my various wells and the values associated with them, the statistics that we've produced, and of course the histograms. Finally, a nice and easy but useful tool is to export as a image. So with that, I'd like to quickly return to my split plot here, which is a nice image. So here I've quickly created my nice image with my statistics, and I then want to either can copy as a bitmap or a enhanced meta file, which is then something I can easily paste into PowerPoint or some other package for presentation purposes. So with that, I'd like to conclude this demo of the Blueback Investigator 4, and I would now like to take some time to answer any questions that you can enter into the questions dialog box just now, or you can always contact us afterwards. So I'm just going through the questions now. There's a question if the webinar was recorded. The answer is yes, we'll record the webinar and we'll provide a link to you all afterwards. There was another question here if the statistics were exported to Excel. Yes, when you export to Excel, you'll see all the data that makes up the investigation and the statistics in your spreadsheet. There's one more question here about which versions of Petrel we support. So right now we support Petrel 2014, and soon we will provide support for Petrel 2015 as well. So with that, I'd just like to say thanks for joining, and we will send out a link with the response to any of the questions that we missed. Thanks for listening.